Hi everyone, in this video I'm going to talk about three-level database architecture. I will also talk about common functionalities that are expected from a database management system. So let's start with the three-level architecture first. Now, when it comes to databases, one of the main goals is to hide details of implementation of how the data is stored or how it's modified, how it's manipulated. It's important to hide these details from users or application programs as well. Now, this is called data independence, the immunity of user applications to changes made in the definition and organization of data. So these user applications, they don't need to concern themselves with the low-level details of data storage and manipulation. This is again like the example of knowing how to drive a car versus knowing how the engine of the car works. You don't really need to know the details of how the engine works. You just need to know how to drive a car. This is a reason why there's a three-layer architecture, and the three-layer architecture is the most widely adopted type of database architecture in relational database management systems. So this starts with ANSI, American National Standards Institute, and Spark organizations. They come up with the three-layer architecture in the 70s. Even though this is not an official standard, it becomes widely adopted, and most databases, they implement this architecture, most database management systems. The ANSI Spark model has three-level architecture. These levels are made up of external level, conceptual level, and internal levels. And these three levels, they aim to provide a personalized view of the data. Distancing internal level from external helps preventing user interaction with how the data is physically stored. The whole point of layering is that these layers can operate separately from each other, and basically if there's change to one layer, the goal is that the effect to the other layers is minimal, right? Otherwise, if everything is one layer and you make one change, it can affect all the other operations. But if you have layers or levels, you can make change to external level without actually messing with the internal level. Okay. This way, a DBA, a database administrator, can also change database storage structures without affecting users' view of the data, meaning that he can actually make changes to internal layer, and people or user applications or users will still get the same view to the data, actual data. Their data, the way they see data will not change. In this architecture, external view is the level where the user or the user application programs interact with. Users can view data, store or modify it, but they are not able to change the inner mechanisms of the database, how the data is stored, right? The actual physical storage parts, the users don't have any say on that. They can just see, modify, store, but they cannot get into the details of how it's done. On the other hand, conceptual level, is more like a bridge between internal and external levels, and provides a mapping and independence between internal and external levels. So you have entities that you want to store data about. their relationships, their attributes. It's more of an abstract design. This goes into conceptual level. Okay, and the internal level is actual physical storage of these entities, relationships, and attributes. On the other hand, internal level handles how the actual data is physically stored on the computer system. And now, why do we need to restrict user access to data or inner layers? Another thing about three-level architecture, you may restrict how different users see data or how much access they have to data. Now, first of all, not every user has the same privilege in different organizations. Some users can see sensitive data and some are not supposed to. For example, think of a company where a low-level employee is allowed to see how many stocks for each product they have in the company, in the storage, but a manager can actually change the stocks. Or a manager is also allowed to see salaries of the people, other employees, but a low-level employee is not supposed to see the salaries of other employees. So, different organizations have different needs for restricting data, giving different privileges. Some databases, some users are not allowed to create any records, enter any data. They can only see data, or they're not allowed to change existing data. For example, you can go to Amazon website and check out the products, but you can't really change the number of items available without signing in first. So when you sign in, you become a member. You're a different user type now. But as a regular user, you can just visit the site, but you can't make any changes. You can just see what's there. So that's type of restriction for the database, for the data. So that's one reason for data restriction. Another reason is users should not deal with physical storage details. Just as you don't go into your car's engine and start messing with it unless you know about what you're doing, but you take it to a mechanic shop, right? And if there's anything that needs to be done, they change it. Or actually, when you start the car, when you switch the key and then you start the car, I mean, you don't need to go into engine and light stuff up to start the engine. You just rotate your key, and that starts the car for you. You don't need to go into lower level details. Okay, so you just work with the interface that is provided to you. That way you save time, so you can work on details of your actual application, what needs to be done, so you take care of your user's need instead of dealing with lower level database details. Another reason, layer allows changes to be made without affecting other layers. Internal structure is unaffected by changes to the physical aspects of storage, because again, we separated external level and internal level, so changes to how you physically store data will not affect how the users see the data. Okay, that's another aspect. And DBA can also change conceptual structure, and it won't affect the users. So he can maybe, for example, you have database tables where you use 40 characters for storing the name, and people can still see these tables on the external level, right? They can see the names of the customers or whatever in the database. And if the DBA, database administrator, goes to the conceptual level and changes the number of characters for storing a name from 40 to 45, that change is made in the conceptual level, and people who have access to external level will not see that change. will not know what changed in the background. So again, that's another uh, benefit of having 3 layers for database architecture. So let's talk about some more detail about what these layers contain. External level, as I said, it's the layer where application programs and users interact with data. It's more like an interface. Conceptual level, it contains entities, attributes, relationships. For example, a university is an entity, right? Um, or we can actually narrow it down. We can say a class is an entity, a university course is an entity, and its attributes can be things like what time is it at, its name, its course number, students, right? Or a student can be a different entity, and a relationship can be between a course and an entity, as a course and a student. That the student takes a class. So for each student, they will be taking a class or more than one class. And student is an entity, course is an entity, and the relationship is that a student takes the class. So we'll get into more details about entity relationship modeling. Just know that an entity is a real world thing that has some attributes, properties, and these are stored in the conceptual level. Some other things that are in the conceptual level are data constraints, such as you bring certain limitations to the data so that things make sense in the database. For example, um, let's say you have an organization that has 50 employees, and at the maximum they can have 100 employees. So you bring a constraint to the data. User cannot enter a number higher than 100 for the employee number of that company. That's a constraint that is placed there to make sure the data always makes sense in its own context. Some other things are information about data, which is called metadata. It's like a catalog. It explains what type of data is stored, what type of entities and relationships exist for the database. And then we also have security integrity information. We'll talk more detail about these later. On the other hand, internal level deals with storage space allocation for data and indexes, record descriptions for storage, data compression and encryption. So really low level stuff that users don't need to know anything about. Um, Now, according to the founder of the database management systems, ECOD, there's eight services for every database management system should perform. In the book, they also add 2 more to these services. So the first one, obviously, database is expected to store data, retrieve data, and it should also provide tools for users to change, modify data, or delete data. So these are basically called CRUD operations. C for create, R for read, U for update, D for delete. CRUD operations. So these are the most basic functions of every database. If a database don't have this, it's not a database. The second thing second functionality of a database management system is that it needs to provide a data catalog. Okay, so catalog should have information about schemas, users, applications, any type of data about the data it stores. This is an important thing. Transaction support is the third thing a database is expected to do, database management system is expected to do. Transaction support feature prevents inconsistent data. It is essential if a problem occurs during a transaction, such as computer crash, power outage, etc., software failure, and transaction partially goes through, it will cause inconsistent database. Remember, inconsistent data is one of the worst things that can happen in a database because it's just waste of time, waste of storage, a lot of money. So transaction support, this feature basically tries to prevent inconsistent data. Now, as an example, think of transferring money, right? You transferring money, and just as you transferring the money, there's like a power outage or something went wrong with the software. Now it deducted the money from your account, but it actually never sent the money. Okay, so the money basically disappeared. The money is deducted from your account, but your debt is not paid, so it's simply lost. So this transaction support needs to make sure a transaction, all transactions happens or none of them happens. Okay, so this is a system that is expected to be in a database management system. The fourth functionality is concurrency control services. Databases can be remember from the first video, a database is a shared resource. A lot of users connect to it, and it's a centralized resource, meaning many users will have access to it concurrently, and there has to be a system that makes sure the changes made to the database is consistent. Okay, it does not create inconsistent data, because let's say I'm accessing a certain data and another person is accessing to it, and what if you're modifying it at the same time? So that should not be happening. Therefore, there has to be a concurrency control system. Number 5, recovery services. Database management systems are expected to have mechanisms that recovers the database in an unexpected event such as a system crash, hardware or software failure. Number 6 is authorization services. It's an important one. Again, remember, it's with the users and privileges, user access, data retrieval, update, privileges, authorization. These are provided by authorization services. You don't want everybody to have access to everything, and you restrict access using authorization services. So a legit database management system has to have authorization services. Support for data communication. Number 7, you should be able to communicate with other software, because databases are rarely used on their own. Therefore, they need to have certain tools for communication. Integrity services. Number 8, it should have the capability of enforcing constraints on the data that will preserve data integrity. I gave the example earlier with the company having 50 employees, but maximum they can have 100, right? So basically, integrity services allows you to put constraints on the data, so the users cannot enter data that does not make any sense for certain data within its own context. Okay, or you can also restrict types of data. The data type, like a phone number, is not supposed to be a string of characters, or a zip code. Has a certain number of digits, etc. These type, there's a lot of different types of constraints you can put on the data, and integrated services help with this. Number 9, services to promote data independence. And number 10 is the utility services. Basically, all the tools that will make a DBA's life easier, such as some interfaces or some programs, services that will help the user for the database or DBA import, export data or import-export files, some statistical tools, maybe some reporting tools, and index organizations, and sometimes even memory management tools to make it easier and a smoother experience to run a database. So these are the things that are expected from a database management system, and we talked about the three-layer architecture. In the next video, I will get into chapter 3, and I'll see you in the next video.